Welcome to the second video of calculation examples of moment of inertia. Here we are given with four shapes. The one is not visible right now. So the first shape, let's start with the first shape. We are given with the axis as x-axis, the y-axis. We are required to find out the moment of inertia about the x-axis. That means if it was drawn 3D, if it was a triangular beam, then the bending would have been occurring about the x-axis. So the moment of inertia about x-axis will help this beam to resist the bending about x-axis. So that is why we are interested in calculating moment of inertia in x-axis. Similarly, if it was a circular beam and the bending would have been occurring like this, so Ix will help the beam resist bending about x-axis. Well, anyways, let's start with calculation of moment of inertia. For the first shape, we know that moment of inertia for triangle is bh cube over 36, which we already discussed. It was for this triangle. The same formula applies for the triangle which is not a right angle triangle. Here we are given with base as 12 inches and the height as 6 inches. Substituting these values in the formula, we get 12 multiplied by 6 cube divided by 36. The moment of inertia about x-axis comes out to be 72 inch 4. The unit of moment of inertia is length to the power 4. Starting with the second example for moment of inertia of semicircle. We know that for circle the moment of inertia is pi d4 divided by 64. That is formula for Ix here. Here the axis will matter. Since in previous example it was a full circle, so the formula remains same. Here the axis will matter since if we are considering this part as the diameter. So diameter would be in our case here 2 times of radius, that is 8 inches. The diameter is 16 inches here. Substituting the values in formula, the formula first we need to modify the formula, that is it should be divided by 2 since it is a semicircle, not a complete circle. Now we have to substitute values in this formula. So the moment of inertia about x-axis comes out to be 1608.5 inch 4, which is required for the same given shape. Now let's begin with a void rectangular shape. We know that the moment of inertia formula for the rectangle is bh cube over 12. Now we have to break it in two parts since this part is a void. So we have to neglect this part playing. So the moment of inertia of outer, the moment of inertia of inner. There is, we know that outer B is and outer height is 10 inch. For inner, the base is 6 inch and the height is 8 inch. Substituting these values in the formula, we get 8 into 10 cube divided by 12 minus 6 into 8 cube divided by 12, which is substituting in this formula these values. So the moment of inertia comes out to be 410.667 inch to the power 4, which is the required answer. Starting with the fourth example, the question is given with a circle and a void circle. The outer diameter is 12 inches, the inner diameter is 8 inches. We are interested to find out moment of inertia about x-axis. Moment of inertia about x-axis or y-axis or any other planar axis such as x prime, y prime or simply y would remain the same since it's a symmetric shape with respect to all the axes. So starting with, we know that for the circle the moment of inertia is pi d4 divided by 64. Since the inner area is void, so we need to neglect this. This would be outer and this would be inner. The only variable here is diameter. So the outer diameter is 12 inches and the inner diameter is 8 inches. Substituting these values in the given formula, which is not only moment of inertia about x-axis, it is also moment of inertia about y-axis, x prime or any other y prime axis. Keep posted with further examples of moment of inertia, including parallel axis theorem of composite shapes. Thank you for watching.